Question 23. Two objects P and Q are moving in a horizontal circular path at constant speeds. The mass of Q is 3 times the mass of P, and the speed of Q is 2/3 of the mass of P. If the radius of the circle along which Q moves is 4/3 the radius of the circular motion for P, which of the following is true for the ratio of the centripetal forces acting on P and Q? Okay, so we have two objects moving in circles. This is again a relationship or a ratio question, and we're asking what is the relationship between the centripetal force on P and Q. Okay, and once again, as with ratio questions, the numbers, the exact numbers are irrelevant. It's the relationship between them. For example, well, let's just do the example. So the force on, let's start with P. The centripetal force of P, it says the mass of Q is 3 times the mass of P. So we're going to say that the mass of P is 1, and therefore the mass of Q would be 3. 1 kilogram, 3 kilograms, right? It doesn't matter. If I could say that P is 2, and then Q would have to be 6. 2 times 3 is 6. But obviously, I'm just going to pick the easiest numbers, and 1 is 99% of the time the easiest number to use. Then it says the speed of Q is 2/3 the speed of P. So if Q is 2/3 the speed of P, what's the speed of P? You got it. It's also 1, and therefore the speed of Q is going to be 2/3. If the radius of the circle Q moves is 4/3 that of P, what's the radius of P? Yeah, once again, it's just 1. So this question is actually pretty straightforward because everything for P is 1. They're telling you how Q relates to P. And if we do this operation here, we simply get the centripetal force of P is 1. What's the centripetal force of Q? Well, it said that the mass was 3 times, so this becomes 3. The velocity was 2/3. So that becomes 2/3, and don't forget to square it. And it said that the radius was 4/3. And then you kind of end up with this messy thing. But once we simplify this messy thing, well, let's see what happens. We're going to get one of those answers, A, B, C, or D. So first of all, square the 2/3. Then you can multiply the top out. So at this point, we've got 12/9 divided by 4/3. I'm just going to move over here. 12/9 divided by 4/3 is the same as 12/9 times 3/4. And 12/9 times 3/4 is 36/36. Look at that. Which equals 1. So look at that. The centripetal force of Q is also 1. So in other words, they're the same. They have the same centripetal force because of this one has 3 times the mass, but it has 2/3 the velocity. So it has more mass but less velocity, and more radius, but since the velocity is squared, anyway, it ends up being 1. So the answer is they're the same. The answer is D. So that's a great ratio question. Okay, on to the numerical response. Classic, what's the slowest velocity? You got a motorcyclist, stunt rider on a motorcycle going around a circle, and they want to know, here's his motorcycle, here he is, he's on a motorcycle. That's not the greatest motorcycle. The diameter of the loop is 7.5, then the slowest speed. So when they're asking for slowest speed at the top of the loop, If they're asking for slower speed, let's ask ourselves, what are the forces acting here? Well, we've got gravity pulling down. You've got the normal force of the track pushing down on the rider, and the centripetal force is always towards the center of the circle, so that's always down. But when they're asking for the slowest speed, the minimum velocity, or the biggest radius, then one of these becomes zero, and it is this one here, because as you slow down, as you're going around the track, you put less and less force on the track, and eventually at the top only, you'll always have force on the track at the bottom, right, because gravity's pulling you down and the track is pushing you up. But at the top, you get less and less normal force until it eventually becomes zero as you go slower and slower. So this is zero, and therefore, when I write this formula here, please remember that the centripetal force is a combination of the other forces acting on it. Then, since Fn is zero, we just get this Fc equals Fg, mv squared over r equals mg. M's cancel out, and the M's only cancel out when they're asking for the slowest speed. And we're asked, what are we solving for? Velocity. I'm just going to do it over here. Velocity equals the square root of rg. Very simple. Put those numbers in, and you end up getting, what is it that you get for that? You end up getting 6.06, and be careful here because that's 6.06 meters per second, and they want the answer in kilometers per hour, and it turns out to be 21.8 kilometers per hour. On to number 25. Number 25, the elastic constant of a spring is 875 newtons per meter. If the spring is compressed so that it stores 56.4 joules of elastic potential energy, then the force that causes the compression. So we're given a K value. We're given the elastic potential energy that the spring stores, and we're asked to find, force. Okay, so when we look at those variables, there's no formula with those three variables in them. However, if we're asked to find force with the spring, then we're talking about Hooke's law. We're talking about this formula here, and what are we missing in that formula? We're missing x, which we can get from this formula. The elastic potential energy of a spring, you can put in the 56.4 here. The 875 there, and solve for x, or you can manipulate the formula for x, and you turn out to get an x value of 0.359. meters, at which point you can just plug those numbers into this formula. And that turns out to give you an answer of 314. And in this question, since they want the answer like this, and they want only the value of B, and then it says record your 3-digit answer. So there's your 3-digit answer right there, 3.14. So even though it just says B, it doesn't say A.BC, they still want it 3 digits. So the answer to the question is 3.14. Okay, we got 2 questions left. So here's another skateboard question. And what, okay, this is a good question, because this one is asking you to calculate the speed at this point here. So there's the skateboarder at this point, and they've made this question a little easier. Instead of telling you what the velocity and the height at this point is, they've given you the mechanical energy. So they're saying at this point, the mechanical energy is oops, 2,580 joules. When he passes point Q, he is 1.3 meters above the hill. What is the skateboarder's velocity? So as I said, they made it a little easier by giving you the mechanical energy, so you don't have to calculate that. But the principles are all the same. It's going to be that the EM before equals the EM after. And in this case, we don't need to break this down into EK plus EP because they've given us the value already. So I'm just going to leave that as EM. But this one, I'm going to have to break out into EK plus EP prime. And we are asked to solve for the speed. So we're going to get, let's see, if we want to do the, at this point, you can decide to do it a couple of different ways. One way is you can solve for this, right, and then just subtract it from this to get the EK, and then use this formula here to get the velocity. And in many ways, that could be the best way to do it. It's not all in one step; it's multiple steps, but it keeps things a little simpler, and then you can see exactly what you're calculating. So you calculate EP by going MGH to this point here, and then you get that value, and you would subtract it from this value here. That would give you your kinetic energy, and then you would use this formula to solve velocity. So you can do it, absolutely, you can do it that way. If you want to do it in one formula, then we're going to do this, where first of all, let's just get EK by itself. EK prime equals EM minus EP prime. Move that over there. Then we're going to have to expand everything. 1/2 mv squared equals EM does not get expanded because EM is we already have a numerical value for EM. Minus mgh. That's EP. And then you're going to solve for V. Now, this is why actually I recommend doing it the first way I showed you, doing this first, because this formula manipulation is going to get quite intense. So what we would do is we would multiply both sides by 2. Let's actually extend the page here and multiply both sides by 2, so you're left with mv squared equals 2 times this whole thing. Right? We just got rid of the half there by multiplying both sides by 2. Then you divide both sides by m, divided by m. Divide the whole thing by m, and don't cancel this m out with this one. This m does not cancel out with that m. And then you take the square root. So you end up with this formula, which is a little cumbersome. The square root of 2 times EM minus MGH all over M. And then you can substitute the numbers in and get the answer. So I'm just going to do that. So it's going to be V equals the square root of 2 times 2.58 E3. Oops, don't put a bracket there. Minus, and then make sure you put this whole thing in brackets, the mass. What was the mass? And the height, is it 1.3? Otherwise, you have to put that whole thing in brackets, divided by 58. Right, so that will give you the answer. Just make sure you put it into your calculator correctly. And personally, I would do that in multiple steps on my calculator. This is what I would do. I would go 2.58 E3 minus, and then I will put a bracket, 58 times 9.81 times 1.3, end of bracket, and then I would hit the equal sign, and I would get 1,840, and then I would go divided by 58. So you calculate that answer divided by 58, and I get 31. And then, did I do something wrong here? I would take the square root of that answer. That's not the answer. What did I plug in wrong here? Oh, what did I plug in wrong? I forgot to multiply by 2. So let's go through that again. 2.58 E3. So yeah, easy just to make a mistake on this one. Minus bracket 58 times 9.81 times 1.3 equals 1,840. Then you've got to multiply that by 2 times 2 equals 3,680 divided by 58 equals 63.45. Square root of the answer, 7.97 is the answer to this question. All right, okay, let's get on to the last question. That one took a little while. Here we go. We've got a 5 kilogram mass is riding on a horizontal platform, horizontal. So we're talking about horizontal circular motion. The mass is held in place by the friction at a distance 5.2 meters from the center of rotation. The coefficient of friction between the platform must be at least. So we are looking for mu, the coefficient of friction. We have the mass. We have the period. And we have the radius. This is a good question. This question makes your work a little bit. So what forces are acting in this? It's a horizontal question. So the centripetal force is caused by the frictional force. Those are our two forces, and this is going to be mv squared over r equals mu Fn. And mu Fn is Fn in horizontal problems is always equal and opposite to Fg, so it's mg, which is a good thing. And we are solving for the coefficient of friction. So the coefficient of friction right here, mu, equals v squared over rg. And at this point, we have to ask ourselves, what do we have and what do we need? Well, we have the radius. We have gravity. We don't have the velocity. So we need to calculate the velocity. Can we calculate the velocity? Absolutely, we can, because we have the radius and the period. And we can use v equals 2 pi r over t to calculate that velocity, which I'm just going to tell you the answer. 2 times pi times 5.8 divided by 8 is 4.08 meters per second. And now we can plug that velocity in, and radius and gravity, and it turns out we get an answer of 0.33. And remember, the coefficient of friction has no units. So that's the answer to that question. That ends the practice test. Oh my gosh, 5 videos. Holy smokes, that was long, but I hope you got it. And when you get the unit test, the questions are going to look extremely similar to these ones, obviously with different numbers. So please go over this several times, or not several times. Please make sure you go over all the videos. All right, we will see you soon.